Hi, thanks for your interest in Texas High Energy Materials and our prototype aircraft fuel bladder discussion. Today I'd like to show you our progress on a new self-sealing, crash-worthy, and ballistic-tolerant fuel bladder to replace legacy systems in our military aircraft. Texas High Energy Materials conducts world-class materials research, development, and commercialization for military applications. The more extreme, the more we enjoy the challenge. Texas High Energy Materials has been in business for 16 years now, with our over 3 decades of experience with DoD and materials development. The company has multiple U.S. patents for our intellectual property, including a U.S. patent pending for this project as well. As a small business, we can conduct project management and commercialization without many of the encumbrances found at larger organizations, while minimizing overhead rates that hinder research and development. We have a fully equipped R&D center located in Austin, Texas, but are prepared to commit to interstate and international collaborations to expand our manufacturing capabilities. Here's why the Navy needs better bladders. Fuel bladders, to be exact. When we first fielded fuel bladders in World War I, they were made of vulcanized and untreated rubber and reinforcing fabric. Since that time, we've made great progress to improve safety, durability, and performance. But there are still fuel bladders in use today that use vulcanized rubber as the primary material. We use it because it works. Natural rubber swells when in contact with leaking jet fuel and self-seals from ballistic impacts. Unfortunately, natural rubber is inconsistent due to high variability of weather and atmospheric conditions at rubber tree plantations. These fuel cells are still made by hand through an artisan process that can take up to 60 days to make a single bladder. Quality control of these handmade bladders is lacking and leads to excessive amounts of rework and scrap. In addition, the slow manufacturing process leads to supply issues which consequently lead to significant reductions in combat readiness for our military aviators. Better fuel cells for the military still have to be held to the highest standards of toughness that even currently manufactured bladders can find hard to pass. The goal of our project is to develop and commercialize a crash-worthy, ballistic-tolerant, self-sealing flexible fuel bladder for combat aircraft. The flexible bladders pass a number of performance tests based on MIL detail 27422 Foxtrot, including the ability to self-seal after being struck by tumbled .50 caliber NATO bullets and not rupture when dropped from 65 feet. These standards are written in blood, based on prior experience. The drop test simulates a crash or very hard landing of a helicopter, which in many instances is survivable to the pilot and crew. But a ruptured fuel bladder upon impact is a deadly fire hazard that in most instances turns a survivable incident into a deadly one. So our challenge is to improve on the existing rubber fuel bladder, making a tougher, safer, more resilient fuel storage system. If we can improve manufacturability to strengthen and speed up our existing fuel cell supply chain, we'll have achieved a rare trifecta for DoD research and development. Does anyone remember the callback from the 70s TV show, The $6 Million Man? Better, stronger, faster. Texas High Energy can do that too. Our emerging fuel bladders are made from highly consistent and readily available synthetic polymers commercially sold in large quantities to a wide variety of markets. We've also demonstrated an extremely fast processing time and high level of automation for our material processing, enabling a completed fuel bladder to be made in hours, not months. Our fuel bladders have been demonstrated to immediately and completely self-seal punctures through a novel mechanical process that, unlike incumbent and other reactive self-sealing technologies, will not prematurely or accidentally activate or diminish in reactivity over time. Complete closure of a ballistic puncture through our technology occurs in milliseconds. These pictures are actual shots taken from our own drop and ballistic puncture testing. Since then, our bladders have undergone formal military testing, with our bladder passing all tests provided. The only test left for formal MIL detail acceptance is a low-temperature gunfire test, where our fuel cubes have to be chilled at -40 degrees for 4 days prior to the ballistics test. We've passed this test in our laboratory, and only need additional range time to achieve it for the DoD. The military range testing for ballistic tolerance and crash-worthiness were conducted in November of 2024, in conjunction with an automated manufacturing process development project under a Defense Logistics Agency SBIR, that parallels and complements this project's development, particularly with the development of new and improved manufacturing methods. SBIR work is complete, and independent testing concluded. The military tests allowed us to bring the technology readiness level of the fuel bladder project to 7, with formal military demonstration of the prototype at the conclusion of applied development and validation phases. To be clear, Texas High Energy Materials fuel bladders have completed independent testing, demonstrating immediate and complete self-sealing capabilities. We've passed the 65-foot crash-worthy drop test and shown ballistic tolerance of even 20mm Vulcan ballistic impacts. Our proprietary synthetic material is available in large quantities, easing an already strained military supply chain. Additionally, the material allows for reliable and consistent self-sealing that doesn't prematurely activate like current natural rubber products. Finally, our bladders can be produced in hours, not days or even months. We know that mission is being accomplished today with the current state-of-the-art, but it's clear that the advantages and benefits of pursuing new ways to construct and manufacture fuel bladders for military aircraft clearly outweigh maintaining the status quo. Our immediate goal is to continue pursuing military range access to complete the final low-temp gunfire test. After that, we're looking directly to transition advocates with the assistance of fuel bladder manufacturers and suppliers. There are military aircraft still utilizing these vulcanized and natural rubber fuel bladders, and the intent is to keep these aircraft in service for many years to come. Texas High Energy Materials wants to lean into defense prime and manufacturing partnerships to help the DoD improve its fuel bladder needs and improve integrated supply chain issues for the foreseeable future. Our long-term goal is to be a reliable and responsive military vendor, providing crash-worthy, self-sealing, ballistic-tolerant fuel bladders required for combat aircraft. A big part of that long-term goal includes having our signature line of advanced polymer crash-worthy bladders supplied to North American manufacturing partners, along with our other advanced polymer and composites products, including advanced armor solutions. We are also amenable to discussions about incorporating our intellectual property into your manufacturing process to reinvent the supplier experience for combat aircraft manufacturers by allowing them to sell high-quality, innovative products in a fraction of the time and cost, making quality control and FOD a top priority, and providing industry benchmark customer service. As a research and development firm, we do need to continue to identify and work with stakeholders and champions in the industry, leveraging partnerships and manufacturing alliances to replace the current outdated, poor-performing fuel bladder technology that the DoD relies on today. We strongly believe that teaming with the right partners can provide a win-win for all parties, but particularly for the warfighter, who is benefiting from better, stronger, and faster sealing fuel bladders at a lower cost thanks to the taxpayer funding provided through the Small Business Administration and the DoD SBIR program. It's time to move beyond World War I era technology. Modern combat aircraft require modern flexible fuel bladders. Please feel free to contact us through our CEO, Al Perez, if you'd like to learn more about our fuel bladder technology or our other innovations, including omniphobic coatings that we've applied to the V-22 heat exchanger for anti-fouling purposes. If you have challenging material science requirements, we can help you make them better, stronger, and faster. And did we mention that we defeated the 20mm Vulcan? Thanks for your time. Looking forward to talking with you.